Hello guys, so for question number 1, a ball is released from rest and accelerates in the positive direction down an inclined plane as shown by the graph below. So in this case we have a constant acceleration, right? And you can remember that acceleration is basically the constant rate of change. In velocity. So in this case, we basically have an increasing velocity. The graph below represents the motion of a car traveling horizontally along a straight stretch of a road in the positive direction. Refer to the information and graph shown below, which best describes the magnitude of the velocity for the car. Now this is constant velocity. Now again, you can also find the slope of velocity. Average velocity equals to change in x over change in t. You can just find the slope here. 10 divided by 2 5 meters per second. So just constant velocity is fine. Constant rate of change, that's fine. Okay. And then here for number 3, at which moment in time by letters A through D will two runners represented in this graph have the same speed? So speed equals distance over time. In this case, runner 1 has the same position overall. He is not moving. Runner 1 is standing still. And runner 2 has a speed. However, the answer will be they will never have the same speed. Why? Because the distance covered by runner 1 will be what? Be 0. So the speed for runner 1 will always be 0. For question number 4, the graph below represents the movement of a toy car. Which of the following is the car's velocity at t equals 2? Over here, we also have a position of 4. Therefore, 4 meters over 2 seconds equals 2.0 meters per second. That is our velocity. The graph below shows the velocity of a car at 2-second intervals. Which of the following is the acceleration of the car? Now here, acceleration is equal to change in v over change in t. That's our slope. Our slope here is acceleration. So we just have to find the slope, and we can just choose. I chose this point here. So now change in velocity here equals 25 meters per second over change in time, 10 seconds, equals to 2.5 meters per second squared. That is our acceleration. Now question number 6. According to the information and graph above, what is the displacement of the car between T1 and T4s? So T4s is over here. We have a position of 20 meters. And remember that the displacement is equal to x of f minus x of I. And then we have 1 here to 5 minus 5 meters is equal to 15 meters. Number 7, an automobile was moving at 15 meters per second and accelerated at 2 meters per second squared for 10 seconds. Which of the following was the final speed? So for this one, we have that acceleration is equal to 2 meters per second squared. BI over here is 15 meters per second. The time is equal to 10 seconds. We're trying to find for BFF. For this one, you can just use the acceleration formula. A equals change in V over change in T, which equals BFF minus BFI over T. We just plug in meters per second squared is equal to something minus 15 meters per second over 10 seconds. We solve for this equation, so we basically multiply 10 seconds times 2 meters per second squared plus 15 meters per second, which equals to 35 meters per second. 20 plus 15, yep. Now the speed of the car is decreasing uniformly from 35 to 15 meters per second. In 4 seconds, the magnitude of the car acceleration is. So for this, we also use the same formula. For number 9, we use acceleration formula. This will be change in V over change in T equals BFF minus BFI over T. Here we have, we can just plug in, so our BFF is equal to 15, BFI is equal to 35, and our T is equal to 4 seconds. We just plug this in, 15 meters per second minus 35 meters per second over 4 seconds. This equals to negative 20 divided by 4 meters per second. This is equal to negative 5 meters per second squared. Now for this, it's just asking for the magnitude, in this case magnitude. So we can just turn this into positive, and that is our answer. Now for number 9, a student throws a rock upwards. The rock reaches a maximum height of 2.4 seconds, and after it is released, how fast was the rock thrown? For this, you will have to remember your equations. Or not remember, you have them with you. And I believe for this one is, let me check really quick. Actually, I have them written down here. In this case, we have our 4 big equations. And we can just, in this case, use this one, the second one. So we can use for question number, oh, this was for question number 8. The next one is question number 9. So now we can just use BFF equals BFI plus a change in T. And we have our T equals 2.4 seconds. And then our, in this case, acceleration is equal to negative 9.81 meters per second squared. And then we have our BFF, which equals 0. So now we can plug in. In this case, we're solving for BFI. Why? Because how fast was the rock thrown? So in this case, we can rearrange. So it will be BFF minus a change in t equals BFI. We just subtracted this and subtracted this from this. So now we plug in. And you should get here negative negative equals positive. This should equal to 23.5 meters per second. Number 10, a ball initially rolling at 10 meters per second comes to a stop in 25 seconds. Assuming the ball has a uniform acceleration, how far does it travel during the time interval? This is for question number 10. For that question, we're going to use this equation. Well, we can use different equations. In this case, we can also use this equation, the first one. It's more simple. Why? Because we're giving the seconds, t equals 25 seconds. We're given the initial, which is equal to 10 meters per second, our final, which is 0 meters per second, and then we just plug in 1/2 10 meters per second plus 0 meters per second times 25 seconds. This should equal to 125 meters. Now we go to number 11. An airplane initially travels at 10 meters per second. When passing the acceleration line, the airplane then accelerates at 8.0 meters per second squared until reaching its takeoff of velocity of 40 meters per second. What is the displacement of the plane during the acceleration? In this case, we will be using this equation over here, our last one. Why? Because it basically tells us our initial velocity. We have our final velocity, and we have our acceleration. We can rearrange to solve for displacement. So now we start. BFF squared equals BFI squared plus 2a change in x. So now we're trying to solve for this. I first rearrange my equations and then plug in. You can also plug in and then rearrange. So in this case, we have our BI equals to 10 meters per second. BFF equals to 40 meters per second. Our acceleration equals to 8 meters per second squared. We're trying to find for displacement. In this case, you can first subtract BFI squared. So BFF squared minus BFI squared equals 2a change in x. So you're just subtracting. And now divide by 2a. Divide by 2a here. Divide by 2a. Therefore, our new equation is b of f squared minus b of I squared over 2a equals change in x. We plug in 40 squared minus 10 squared over 2a, or over to 8 meters per second squared. And that should equal to 93.7 meters. So now we have car travels at a constant 60 kilometers per hour in the positive direction down a straight line. Highway, what is the displacement in standard units of the car 45 seconds later? So we have 60 kilometers, number 12, 60 kilometers per hour. So now, first we got to convert the 1 hour into seconds. So we go from 1 hour is equal to 60 minutes. And then 1 minute is equal to 60 seconds. So this would be 1 hour is equal to 360 seconds. So now you have 60 kilometers over 36 seconds times 45 seconds. 45 seconds. And then we're left, seconds cancel. We are left with 0.75 kilometers. And that is fine. That's our answer, kilometers. Now we go to question number 13. A train travels north at a speed of 50 meters per second. A passenger walks towards the rear of the train at a speed of 2 meters per second. A person standing on the platform at the train station observes the motion of the passenger as the train passes. According to the information and diagram above, what is the apparent speed of the passenger with respect to the train station platform? So basically, we can use our displacement formula here. X of f minus x of I. And here we have x of f being 50 meters per second north minus 2 meters per second south, and this is equal to 48 meters per second north. So number 14, a ball at rest falls from a platform above ground. The ball falls freely and hits the ground 1.1 seconds later. What is the height of the platform? So 14, again, a ball at rest. Therefore, our b of I is equal to 0. The ball falls freely. That means 9.8. And time equals 1.1 seconds. For this problem, we can use our third And our third equation here, change in x equals b of I change in t plus 1/2 a change in t squared. So now our b initial is 0, so this cancels out the first part. And then we have 1/2 9.81 meters per second squared time 1.1 seconds squared. In this case, it's asking for the height, and height is always positive, so that's why our answer should end up in positive. We compute that. First, we do the exponent, and then we multiply times 9.81, and then times 1/2, and we should get 5.9 meters. And that'll be it. Thank you.